Homothecy preserve collinearity. Let me take example in GeoGebra. Suppose I have 2 points A and B. I'm going to do a dilation from of point A with center omega. Suppose I'm going to say 2, and B omega come in 2. So if you join these two segments, as we said, A prime B prime will be equal to AB. If you pick any point C on AB, and if you want to do the same dilation of point C with omega, you're going to have a factor come in 2. You're going to have, as you can see here, C prime is on A prime B prime. Okay, and if you move C on this line, the line C prime will move on line A prime B prime. So we say that homothecy preserves collinearity of points. How do we prove it? Suppose HA equal A prime, HB equal B prime, HC equal C prime. Suppose A, B, and C are collinear. Because A, B, C are collinear, we can say that AC equal MAB because they are collinear. But AC, because image of A under this homothecy is A prime, image of C is C prime. So we can say that, or you can, if you multiply on both sides by K, okay, by K, you're going to have KAC equal MKAB, but KAC is nothing else A prime C prime, and KAB is nothing else than A prime B prime. So in that case, since you have a point A prime in common, so you're going to say A prime B prime C prime are collinear. It preserves oriented angles, so let us prove it on GeoGebra. See it on GeoGebra, then we prove it here. So I have point ABC here. If you join it, segment, and you see the angle between these, so you have 116.57. If you do now homothecy of point A with respect to B, for example, let me do it 1.2 this time, and that of point B also 1.2, factor 1.2, and C with W 1.2. Let me, it's very near, let me do it 2.2 each one, 2.2, it's more clear, 2.2 to see it. And if you want to find the angle between A prime, B prime, C prime here, you're going to see that it's also equal to 116.57. You can see here it is 116, and if you move A, no matter where you move A as animation, let me do it, so the angles will be the same, nothing else will differ. Okay, you're going to have the same angle. So that's why we say homothecy preserve angles. How do we prove it? Suppose h of A is A prime, h of B equal B prime, h of C equal C prime. So we know that A prime B prime equal KAB, and A prime C prime equal KAC. Now I want to show that they have the same angle. So ABAC, if you multiply here the angle AB and AC by K, nothing is going to change since I'm multiplying by a number. So KAB is nothing else than A prime B prime, and KAC equal A prime C prime. So they preserve oriented angles. They preserve midpoints also. Let me see it in GeoGebra. So let us do now dilation of WA. For example, let me put -1/3 this time. You have A prime. If you do B with W, -1/3. Okay. Now, if you want to find, let me join this segment, AB, A prime, B prime, and these. Let me delete by mistake this one and the point C. So if you join A prime to A and B prime to B. Let me pick the midpoint here, midpoint of segment AB, midpoint of segment AB, which is small f. Here you can see it's C. It is C. Now if you find the image of C by this homothecy, which was, let me remember, it was ratio 1 minus 1 over 3, CW minus 1 over 3. You're going to get that C prime is the midpoint, as you can see here. It's the midpoint of A prime, B prime, so it preserves midpoint. And if you move C here, always, if you move C here, sorry, so if you move, or if you move C prime, always it will be the midpoint. As you can see, no matter where you move it, C and C prime are the midpoint of AB and A prime, B prime. Since C is the midpoint of AB, it will be the midpoint of A prime, B prime. If you want to prove it, suppose H of A equal A prime and H of B equal B prime. Let C be the midpoint of AB. And let HC equal C prime. We need to show that C prime is the midpoint of A prime, B prime. هلا C midpoint of AB, it means AC equals CB. So if you put K, so you're going to get A prime, C prime equals C prime, B prime, where C prime is the midpoint of A prime, B prime. هلا concerning this circle, suppose you have a homothecy of center W and ratio K, you're going to have another circle, but the radius of the circle will be multiplied by K. Let us see it on GeoGebra. So now we have this circle. I want to find the image of this circle by a certain homothecy. Okay. Suppose from circle C to W, let me say ratio of 2. Let me put it more than 2, not to be overlapping, 3. Okay. So now if you want to find the image of A by 3, here, the image of A, you're going to get, because A is the center, A prime will be the center here, and concerning radius, it will be times the 3. So here, segment AB, and let me do that of B to see the radius by 3. You're going to get another radius A prime, B prime, and times 3. So if you join it, circle will be preserved circle, but the radius of the image will be multiplied by K. So if you do animation here of the point B, as you can see, it will be, okay, as you can see, times K, and always you have the image of a circle is a circle, and the ratio of the radius will be times K. But the area will be multiplied, you know, by K square. Okay. Now in the second video, in the third video, we're going to talk about the transformation of two homothecy and a homothecy, and for example, here we have two homothecy and the translation and the homothecy in the third video. Thank you for listening.